And welcome everybody. Hey, thank you very much for being here for a live stream about OSPF as part of the new CCNA. For those of you who are joining us for the first time, gosh golly, we're glad you're here. And for those of you who've been and seen me before, hey, thanks for coming back. The time means a lot. We all have just a certain amount of time on the planet and during our days with everything else going on. And so what I hope to do is our time together in this channel, I want to trade something that's of value. So you can walk away saying, yeah, that was totally worth the few minutes that we spent together. That's also how I feel about our training at CBT Nuggets. So I wanted to share with you, before we get into OSPF today, I wanted to share with you a little story. It's kind of personal. Jeremy Chara and I have been working together off and on for almost 2 decades, I think, 18 years, 19 years. And I admire... Jeremy and I, we've been both in at CBT Nuggets for a long time and making our content, focusing on it, and we recently had a chance to collaborate on CCNA, and let me tell you, it can be DHCP snooping, which is a great way to prevent what I did back in the 90s on wireless networks, not realizing it was pretty darn malicious, but DHCP, if it's not protected, can be very much compromised and used against the network, or IPv6 static routing, or packet tracer. And I tell you what, every time I show somebody packet tracer, they go, I've heard of packet tracer. But when I show them, they're like, oh my gosh, I had no idea. You build a rack of equipment right there, cable it up, get the command line. So let me know in the next while what your opinions are, what you like most. And then next week, we'll come back, same bat time, same bat channel, and we'll do the one that gets the most votes. That seems pretty darn fair. All right. So let me share with you what I've been working on, and that is regarding OSPF. And let me bring back that screen there for a moment. So these are a few of the videos that I have ready to go. They're in the hopper, all locked and loaded, ready to go. A question I got last week several times was, "Hey Keith," let me put the video on. Hey Keith, when is the CCNA coming out? When is the DevNet content coming out? And the answer is December. And if the question is what year? This year. So it's just around the corner. It'll be released in December. Both of those will be. And so we're super excited about that. Okay, so on to OSPF. So as we take a look at the idea of OSPF, I think it would be really good for you and I to take a look at this video called Dynamic versus Static Routing, because it gives a really good introduction and comparison. And then also perhaps cost, we'll see how it goes, or if we have other questions, we can address those. I also wanted to share with you something darn cool, and that is this. Check this out. So in addition to like talking and discussing about OSPF and how it works, one of the big elements is getting hands-on practice to reinforce it. So if you and I came up to a new router, or a router like this, we can see it's got some IP addresses on 3 interfaces. That looks great. If we wanted to see any routing protocols, any dynamic routing protocols that are running, we could do a show IP protocols, and that would give us the full list of all the routing protocols that are running. EIGRP, RIP, OSPF, BGP. Nothing's here except for because it hasn't been configured yet. So as we get into OSPF, what I think I'll do is, after I share with you a behind the scenes look at a couple of the short videos, I think I'll walk you through some of my favorite commands in the world of OSPF as far as implementing it, verifying it, which interfaces are running it. And in these videos leading up to it, we'll talk about why OSPF rocks and why it's great and how it works. So let me go back to the screen and let me queue this up. And I'll also be watching the queue for any questions that come up as well. All right, so let's go ahead and do this one right here.
It is an important skill to know how to configure and verify static routes.
Well, sorry.
However, in larger environments...
That was at 2x. I apologize. Sometimes I watch myself at 2x and I think, why am I talking so slow in real life? Let me, give me just a moment. Let me line that all up perfectly so you can see it great. All right, here we go.
It is an important skill to know how to configure and verify static routes. However, in larger environments, it doesn't make sense for you and I to configure static routes for reachability to every single network. Instead, we might use a few static routes like default routes in certain areas, but most of the time, we're going to have the routers dynamically learn how to forward packets to remote networks using some type of a dynamic routing protocol. And that, my friends, is what you and I get to start discussing right now in this video. And for this discussion, let's have some fun by imagining that you and I are right here. So this is us. And our goal is to get to some destination. We'll call this just DEST for short. So we're trying to get there. And if we're traveling, let's imagine we're traveling by a vehicle, whether it's a bicycle or a car or whatever. And we have two paths. We have the path on the north side and we have the path on the south side. And which one should we take? Which path should we take? I heard somebody once say, if you don't know where you're going in life, it doesn't matter. Take any path you want. But if we want to get to this destination and we have two options, let's fill out the rest of the journey and then we can make an informed decision. So let's imagine that we have a toll booth. That's good. That'll work. So let's imagine we have toll booths. So this will be toll booth number 1. This will be toll booth number 2. And then as we go further, there's another toll booth. And toll booth 3 and toll booth 4. Now, in various countries, those toll booths may have different names, but it's where you're on a road and you stop and you have to pay a little fee to continue on that road. So these are representing toll booths, and then let's put one more, and that'll be good. So 3 and 4 and 5 and 6, and then that takes us to our final destination. So based on this, which path should we take? Path A or path B? What do you think? I would like your opinion.
So I'm going to cut in right there and ask you, which path should we take? Path A or path B? What do you think? So right now it's like, it's a guess. It looks like 3 routers on the top row, 3 routers on the bottom row. So if you have a guess about path A or path B or an opinion, type that in. I'd love to see it, and I'll continue the video.
Now, you might be saying, well, Keith, if all the costs are equal, let's say it's $1 or €1 or £1 or whatever it is at each of the stops, and all the roads are the same, then it wouldn't matter. I would agree. But if the tolls were different at each step along the journey, then it would matter if we were concerned about cost. So to give us more information about which path we should choose, let's imagine that at toll booth number 1, the cost is $2 or €2 or 2 units. And at toll booth 3, the cost is 10. And at toll booth 5, the cost is 7. And then down here on path B, let's imagine that toll booth number 2, the cost is 3. And at booth number 4, the cost is 8. And at booth number 6, the cost is 7. Now, assuming all the roads are equally good, which of these two paths should we take if we're concerned about cost and getting the best value for our dollar? And the solution to that could be we'll simply add up the cost. So 10 plus, for path A, 10 plus 2 is 12, plus 7 more is 19. I'll put that in a different color up here. So the cost on this path is 19, great. And for the bottom, let me make sure I did that right, 10, 7, 8, 9, yeah. But then path B, the cost would be 3 plus 8 is 11, plus 7 more is 18. The cost here is 18. So if we were being cost conscious, we could go ahead and choose this path because it would be more cost effective or a better value or a better path. So let's take what we know and apply this to routing. Let's imagine that 1, 2, 3, 4, 5, 6, these devices are all not toll booths, but rather they are routers. When we run a dynamic routing protocol, we enable that routing protocol on each of the routers. It's sort of like running an app on your phone. You turn it on, it starts running. Well, if we run a dynamic routing protocol on each of these routers, that allows these routers to talk to each other and communicate information. And once we do so, R1 will learn from R3, and we don't have to manually configure static routes because R1 can dynamically learn information about how to reach remote networks via R3, and R5 can learn from R3, and so forth and so on, using a dynamic routing protocol. Now, not every dynamic routing protocol is created equal. There are 2 big categories regarding dynamic routing protocols, and it's based on how they operate. One of them is referred to as a distance vector routing protocol. A distance vector routing protocol. I'm going to put a little symbol here of not so great. And when I think of distance vector, here's what I think. I think, okay, how far is it? What's the distance to get to a given destination? And vector, which direction should I go? So for me, that's the way I remember it. How far is it? What's the distance? And which vector or direction should I take? And one of the most oldest dynamic routing protocols on the planet is a distance vector routing protocol called RIP. Not as in rest in peace, but Routing Information Protocol. And people who are still using it, if they are, they use version 2 for a lot of good reasons that we can talk about later. But I just want to introduce it as a distance vector routing protocol. But it's not, the reason it's frowning here, it's not that smart. Because distance vector routing protocol, specifically RIP, it doesn't take into consideration the actual cost of each of the links as we go from our source to our destination. Instead, it just does hop counts, hop referring to every router in the path. So in distance vector routing protocols like RIP, it would say, okay, to get from here to there, I have to go through 1, 2, 3 routers for path A. So I'll put that in red for RIP. How about that? Let me get red out. So from a RIP perspective, it would be 3 as far as the cost. They refer to that as the hop count, each router being a hop in the path. And for path B, it would be 1, 2, 3 also. So RIP would think that path B is also a hop count of 3. And as a result, these would appear as equal cost paths, when in fact, one is not equal to the other. One is better. But distance vector routing protocols don't take into consideration the factor of cost or how effective a path is. They're just looking at hop count in the example of RIP. So the next question might be, well, what's the other category that is hopefully a lot better than a distance vector routing protocol? And I will put a little line here. And the other family is referred to as link state, as in a link state routing protocol. And a big example of that, a really popular example of that, is OSPF. And when OSPF is used for routing for IPv4 packets, it's referred to as version 2. So if you see OSPF by itself or OSPF version 2, they're referring to routing for IPv4. If you're looking at IPv6, they call that OSPF version 3. So the next thing I'd like to chat with you about is how in the world does OSPF, which is an example of a link state routing protocol, how does it do better in making decisions than its competitors like distance vector routing protocols? And the answer is information. And you might say, Keith, what do you mean information? Well, in OSPF, what we would do is we would train all the routers to run the OSPF routing protocol. They would start communicating with other neighbors that they're adjacent to. These routers would start talking with each other directly, but in addition, they would create what's called an LSA. And LSA stands for Link State Advertisement. And link state advertisements are pretty simple. Let's imagine that you and I are on the phone and we're chatting about router 6. And if I asked you, or if you asked me, hey, can you tell me about router 6? We could say something like, okay, router 6 is connected to, off this interface, is connected to network, let's call this 10.6.0.0. And over on this interface, it's connected to 10.8.0.0 with a 24-bit mask. And other details about that network would be the cost. So that's some of the information that's in a link state advertisement. So here's the secret sauce with OSPF. If we have each router generate link state advertisements, which basically say, yeah, I'm connected to this network and I'm connected to that network, and here's their respective costs. If that information can be forwarded over the whole network so that every router has a copy or has that information from all the other routers, the routers can piece together the whole puzzle. And that gives routers the ability to say, oh, in path A, the cost is, looking at my notes, the cost is 19 from here to there. On path B, the cost is 18. So what that does, it gives routers the ability to collect all that information. They take all those LSAs and they put them into a link state database. It's a collection of the LSA information. And then each router can figure out what the best path is. Let's take a look at the topology. So going back to our topology, if router 6 and router 5 and router 3 and router 4 and router 2 and router 1 all generated their link state advertisements with the information about what networks they're connected to and what the cost is, then a router like router 1 could take all that information, or if this was a router right here, we'll call this router X. If this is a router that has all that data from all the routers, all those link state advertisements, it will know, oh, I see. Router 1's cost going this direction is 2. Router 3's cost in this direction is 10. Router 5 going in this direction has a cost of 7. And this router can add those up and get the cost of 19 for path A. And then it can also be aware, because of the LSAs, all the costs on the bottom path and add them up. And then each router with all the data is going to make a decision. And guess what? It's going to choose the shortest path first. And that's why the routing protocol is called open shortest path first. Every router in the area has all the information about all the other routers in that same area, and then they can make an intelligent calculation on the best path, which includes the cost. And as a result, we can choose better paths as opposed to dynamic routing protocols where cost and other details about the links in that path are not considered. So here's our 3 basic takeaways from this video. Number 1, if we have lots of networks, doing static routes for everything is too tedious, too painful, too much overhead, and if things change, we have to go back and revisit it. Not good. So we use a dynamic routing protocol. And there's 2 categories, 2 families of dynamic routing protocols. One is a camp of distance vector, which isn't very smart. It has a basic idea, but doesn't take into consideration cost. Like with RIP version 2, it's just counting the number of hops, the number of routers between here and there, and that's it. Now, in contrast to that, there's a family of dynamic routing protocols called link state routing protocols. A perfect example of that is OSPF. With OSPF, each of the routers is advertising the details and costs about their networks they're directly connected to. All that information is forwarded to all the other routers in that area. So each router has a link state database, basically a collection of all that information, and then it starts deciding, just like we did at the beginning of the video, which is the best path. Oh, it costs 2 here, it costs 8 here, it costs 7 here. I will go ahead and use this path because it's the shortest path. Open shortest path first is a very popular dynamic routing protocol that is link state. And also, it happens to be the major topic of all these videos in this skill going forward. So I will see you in the very next video as we take a closer look at the interworkings and details of OSPF. Till then, I hope this has been informative for you, and I'd like to thank you for viewing.
Well, you know what? I actually enjoy watching that. So I made that specific video back in August. August 29th is when I made that. And so the series we've been building it. We're going to release it all together here in December. But I've had a lot of fun making it. And there's a couple questions in the queue. I'm going to play one more video, then I'll get that question and any others as well. And then we'll do maybe a quick demo of a lab and answer any follow-up questions. So let me bring back the screen. And let's go ahead and let's do the path cost. That's a very, very useful video. And here it is. Enjoy.
One technique that I have found to be both very fun and effective as I learn or study new things is to put myself and ourselves in the mind of the device. Whether it's a layer 2 switch, what am I going to do? Or whether it's a router or a firewall or some other device. And that's going to help us better understand it. So to that end, here's what I propose that you and I do in this video as you take a look at OSPF cost. Let's draw a topology together, and then as part of that, let's think, okay, what path would we choose and why? And also, as we add more layers and more information, that's going to help us be better at configuring, verifying, and troubleshooting the routing protocol called OSPF when it comes up. So let's begin with a simple 4-router topology. So these represent routers. We'll call this guy router 1, router 2, router 3, and any guesses? Yeah, router 4. Awesome. And let's imagine that each of these routers is connected off to a local segment where there's switches and users and so forth. And let's put a little line there to represent there's a network out there. And then we have some interconnections. And we'll just make this pretty straightforward. Boom, 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 boom. Like that, just like that. And then let's add a connection between R2 and R3 just for maybe a little fault tolerance. So my question is this. If you and I were sitting here, say this is the PC, and let's imagine the PC had a default gateway correctly configured that would use this interface on R3. And if we're trying to get to a server, let's label that here. My question is, which path, if a PC forwards a packet in to the routed environment here, which path should R3 use to forward it to the server? Now, I have heard before, more than once, that the fastest path between 2 points is a straight line. However, we need to kind of flip that paradigm a little bit because not all interfaces are created equal in a network. We might have very slow serial interfaces. We might have moderately slow fast Ethernet interfaces that are at 100 megabits per second. We may have faster interfaces that operate at gigabit speeds and then beyond. So we have to make sure that we're taking the best path based on all the data. So let's go take a closer look at this topology and add some more of that information so we can make an informed decision on which is the best path between the PC and the server. So I would agree that if all these links, all these straight lines represent gigabit Ethernet all the way around, that the fastest path would be, R3 to R4, no problem. But if we start adding information like these links here are gigabit speed, and link between 1 and 2 is gigabit, and between 2 and 4 is gigabit, and I dreamed about this last night, by the way. I was thinking, okay, how can I make this effective and make sure it's fun and people really get it? And this is the topology that I finally came up with. I didn't dream the whole topology. I kind of had the idea in the dream, but it panned out to be this. Let's imagine this link between R3 and R4 is fast Ethernet. So this is 100 megabits per second, and this is 1,000 megabits per second. So the gigabit is 10 times faster than the fast Ethernet. Now, if we wanted to forward a packet from this PC over to the server, which is the best path? To go over the 100 megabit connection or to go around the horn here, which is all gigabit. So let's talk about how distance vector with RIP, for example, would handle it. A distance vector routing protocol would say, oh, it's just one hop using this path here over fast Ethernet, which wouldn't be the most efficient path. And that's why we don't use RIP too much anymore. We're going to use link state routing protocols. And let me put the cost in yellow. Let's imagine that this interface right here on router 3 that goes up to R1 has a cost of 1. So the costs are in yellow. And the cost from router 1 going over router 2 is a cost of 1. And the cost from router 2 over this interface going to router 4 is a cost of 1. And then the cost here on router 4 to get to this network is also a cost of 1. So we're looking at all the outbound paths. That's the costs that OSPF is going to add up to determine the best path based on the least or lowest cost. And it will consider that the shortest path. And then for this fast Ethernet, if we put the egress interface, egress is a fancy word for saying the outbound traffic on an interface. So if this is a value of 10, then OSPF could do the calculation and say, well, if I take this path, I'll put it in green. Brr, 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 brr. Let's figure out what the cost would be. We just add up all the exit interfaces in that path. So that'd be 1 here, 2 here, 3, and 4. So the cost on this path would be 4. And now let's pretend we're still the OSPF router, router 3, and let's calculate the cost if we want to forward a packet over this bottom path right here. So what would that be? I'm asking you to think about that for a moment. What would the total cost be from an OSPF perspective? And if you're saying, well, Keith, we'd add up all the exit interfaces and their costs, which would be absolutely right. So we have 10 here, plus we have 1 here. So the cost on this bottom path would be a total cost of 11. So my question for you, if you and I were a smart OSPF router and we're looking for the shortest path first and use that for our routing table, which path would we use? Path A, a cost of 4, or path B, a cost of 11? And the answer is we're going for the cheapest, lowest cost, and that's how OSPF works. And I've got a follow-up question for you. And the question is how? What do you mean, Keith, how? Well, how did R3, right here, how did he know that R2 on this interface had a cost of 1? And how did he know about R1 that on this interface had the cost of 1? And so forth and so on. And the answer is what? What in OSPF is used? I mentioned it briefly in the previous video, but do you recall what is the thing that is advertised to every router in this area that allows router 3 to have that personal knowledge of the links that are involved on router 1 and their cost, and the links that are involved on router 2 and their cost, and the links that are involved on router 4 and their cost? And
all right, so I am pausing the video right there because I am interested to see if we have anybody who knows the answer to that. What are the advertisement units called that advertise the links inside of OSPF? Mentioned it briefly in the previous video. It's got 3 letters. If you're from Louisiana, that's a clue. And I'll give you a moment to answer those. And I'm having a lot of fun. Oh my gosh, because we'll watch the rest of this video. And then it builds on labs where you configure the basics and how does the router ID work and how do you enable OSPF and then how do you verify OSPF and if it doesn't work, how do you troubleshoot it? So much fun. All right. So for those of you who knew the answer or took a stab at it, way to go, way to participate. Let's go back to the video.
And if you're saying, Keith, I believe it was a link state advertisement, that is exactly right. And because those link state advertisements are propagated through the area, and all these routers in this example are in the same OSPF area, that's why R3 had all the data. it put all those LSAs in what's called a link state database. It's a fancy way for saying all the information about what's going on the network, and it used that information then to calculate the lowest cost, or the shortest path first, to get from here, from itself, to the destination network. And let's do one more for good measure to make sure we all have it. So let's imagine here we have router 1, and it's got connectivity to router 2 and to router 3, and we'll go for a couple more. So there's router 4, router 5, and then we have a final destination network that we're trying to reach. Here's the goal. And we might have a user like this over here. Maybe it's Bob at his PC using R1 as a default gateway. And I'm going to put the costs on all these interfaces so that we can make our best decision regarding which path is going to be used. So I'm going to put a cost of 4 here on this interface, a cost of 5, cost of 2, cost of 3, 1, 6, 2, 3, 8, 9, 2, and that's it. So with all those costs involved, for R1 to make a forwarding decision over here to the goal, which path would it use? That's my question. Would it use path A, the top road, or would it use path B? And I'm going to give you a few seconds to do that math, to think about it, just like you would if you're an OSPF router. And then when we come back, we'll review our answers together.
Do 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 do. No one's coming after that copyright because it's not even close. All right, the added music I just added verbally live. I left the screen up so you could do the calculation, and if you have your best guess, go ahead and put that in the chat, and let's continue.
So the wrinkle that I surgically injected into this diagram is that I included the interface cost, the link cost, on both sides. So R2 has 2 interfaces. Each interface is going to have an associated cost. And the point I wanted to drive home is that when we're calculating the shortest path, we're calculating it in one direction. In this example, it's going from here to here. So all we're looking at is egress or exit interfaces. So we would be using the calculations with 5 and 2, with 6 and 2, with 9 and 2. And all the others are just distractors. Those inbound interfaces don't count for the calculation. So on the top path, path A, it'd be 9 plus 6 is 15, plus 5 more is 20. That'd be the cost for the top path. And for the bottom, it'd be 2 plus 2 plus 2. I can do that one. That's 6. And so OSPF would choose this bottom path as the routes that would be taken, for at least from R1's perspective, as it forwards packets in the direction of the goal. And the reason that R1 knows about all those details is from those beautiful link state advertisements that are being sent by every router, and the collection of those in the link state database, which R1 is using to do the calculations and make its decision on which path is literally the shortest one. Hence, open shortest path first. So in this video, we played the role of the router in making a decision on which path to take based on outbound interfaces and the cost. And just like a bargain shopper, we want to choose the least cost every time to get the best path to the destination. So thanks for having some fun with me and playing along and thinking like the router as we continue our discussion in OSPF, and I'll see you in the very next video. Meanwhile, I hope this has been informative, and I'd like to thank you for viewing.
All right. I had some great questions from the queue. Let me go ahead and grab one of those, and then we'll do some demos on the lab gear. One was, now that automation is here, and I want to be relevant in the future, how would you approach shifting your mindset to learning network programmability? That is a fantastic question. And I would say start with the basic knowledge of networking, because even if, so the big picture is this. We have, instead of, let me give you a quick tutorial on the control plane. So in a device like this one, say hello to my little friend. This is a multi-layer switch. This is a device, a box, that has the ability to do layer 2 stuff, like forwarding frames, spanning tree, trunks, and everything else at layer 2, but it also has the ability to do routing at layer 3, and it does that with something called a switched virtual interface. It's a fancy way for saying it's a logical interface that can drop into the VLANs, and then you assign an IP address and it can do routing. So long story short, layer 2 and layer 3 functionality in one tidy little box. Fantastic stuff. All right, so as far as programming this or working with this, by default, this switch, this multi-layer switch, it's got a control plane which trains it how to behave. Like when it learns MAC addresses on various ports, that's part of the control plane, and that knows how to forward frames because it dynamically memorizes layer 2 addresses on what port, and then it can forward based on that. So anytime we have information that's training the device on how to forward, that's part of the control plane, how to do it. For a router, we'd be using things like OSPF. OSPF, we get neighbor adjacencies, we learn about networks, we read the LSAs, we figure out how to forward. All of that is the control plane. Think of the control plane as the logical of, it's like how to do something. Like how to build a house. It's not building the house, how to build a house. That's the control plane, how to make a forwarding decision. Then when data comes along, then it says, oh, here comes a frame at layer 2. I'm going to forward that. Or here comes a packet. Look at the destination IP address and forward that. So that forwarding of traffic is referred to as the data plane. So the control plane is how to do it, and the data plane is doing it. Now with software-defined networking and with network programmability, instead of connecting directly to this device and telling it with a command line interface of how to do the forwarding or how to do a static route or MAC addresses or anything else that we're configuring, what we could do is have, let me back up a little bit. So from the automation perspective, starting there, it's not SDN, but it's basically network automating the configuration. Instead of going to the command line, we could configure a device like a controller that would then interact with this device, and it could pull information, push information. So we would be still leaving the control plane here, but working with a third-party device like a controller. Let's pretend this is a controller for a moment. And then our software would interact with the controller, and the controller could interact with this device. But it can go one step further. We can have devices that don't know anything on their own about how to forward. And what they could do is they could just be, they don't know anything about how to forward themselves. They have to have somebody else tell them. In that case, we're separating the control plane. We have something else out in the network, like a controller, that's telling this device how to forward. And then when the frames and packets come in, this device could then just forward and not have to worry about figuring out how to forward or where to forward because the controller is controlling all that. So getting back to network automation and programming, it's important to know how the basics work on this device. And then once we understand that, if we want to get into automation, the new CCNA has a whole module on like an introduction. In fact, it's right here for network programmability to kind of give you a warm fuzzy for how it works. I thought it was right here. Hold on a second. Yeah, automation and programmability, where it explains the basic concepts of REST-based APIs, why they matter, how to interpret JSON data, what is a controller, how does that work, and then for those people who have a little bit of programming knowledge under their belts, if they want to get serious into network automation programming, then come see us in DevNet. So in DevNet, there's one module on the basics of networking functionality, like how layer 2 works, layer 3 works, layer 4 works, application layer, the whole protocol stack, basic configuration for Cisco devices. But then it goes into programming, and then it goes into network automation specifically for managing Cisco enterprises. And it's awesome. So for those of you who want to start, like I don't know anything about network automation, start with CCNA. There's the whole module right there to introduce you and warm you up to the idea. Study the basics for Cisco, like layer 2 switching, layer 3 routing, how that all works. Practice, get better and better at it. And then I would go where your heart leads you, really. You don't have to be a network automation specialist to survive and thrive in the next world, the world that we're already moving into. There's plenty of room for anybody who's competent and who's willing to learn new things. So my son is an amazing programmer. His name is Paul, and he's great at programming. He's great I won't say a kid, but he's not a kid anymore. He's 29. He's awesome. And I've got children who are great at art design work, and I've got children who are great at I've got a lot of kids. I've got 7 kids, and they're all great in various things. So I would say whatever you love to do, I would focus on that and become really, really good, and then become aware of the rest. The same is true for network penetration testing, ethical hacking, that kind of stuff. You definitely want to have an understanding of how operating systems work, Active Directory, the basics of networking, because then you can take a box like it's out of reach, like a Kali Linux box, and you can do some white hat hacking and ethically, make sure you have permission and everything else. But it's really tough. In the same sense, it's tough to do hacking against a system that you know nothing about. It's also very challenging to do network automation against devices that a person might know nothing about. So I would say start with CCNA. There's a warm-up for network automation. And if programming and coding is your thing and you want to do network automation, jump into DevNet. You'll love it. The water's great. Come on in. Okay, so I took a little longer than I wanted to on that, but thanks for that question. And I've also got Jake in the audience who's helping me out with questions, which I appreciate that. Okay. All right. Let me go ahead and do a demo, and then I will follow up with any questions that I can interpret through one-layer translation. All right. So this is one of our labs. It's one from OSPF. And by default, there is no routing protocol running on this device, and we can verify that with the show IP protocols. Nothing's running. So to enable OSPF, we go into configuration mode, and we say router space, and then we specify the routing protocol that we want to run. This is sort of like going to our device and saying, hey, I want to turn on this app. I want to turn on this feature. I want to turn on this routing protocol in this case. So if we want to do OSPF, the challenge is, in a few environments, you might have multiple different instances of OSPF running. Most companies may have just like one running at a time, but if you needed to, you could. So there's also a process ID that we can specify. So if you want to use process ID 1 or 21 or 221, etc., just pick one, press enter. That puts us into router configuration mode. Now here's the trick. Just because we're in router configuration mode for OSPF process ID 1 doesn't mean that we're running OSPF. We have to tell the router, dear Mr. Router, on these interfaces you have, I want to enable OSPF and run them on you, which basically means those interfaces, go ahead and start sending and receiving any kind of LSAs on those interfaces. And it also means that include those networks that are on those interfaces as part of OSPF. Now to do it, it's a little bit interesting. Imagine, it's sort of like saying, I want all the streets I live in Las Vegas. I want all the streets that begin with the name M to be part of OSPF. And I would get a certain portion of streets all that started with M. And then like, well, Keith, that's kind of weird. Why would you want to do that? Well, in a router, you can use a network statement. You can say, I want all the interfaces that have the IP address starting with 10 or 12 or 12.5 or whatever length you want. And you can specify with a network statement which interfaces drop in. So it's a network statement or two that we're going to use. Then the router looks at its interfaces, see which ones match, and then it says, okay, those match with your network statement, I'm going to bring you in. And that takes a little bit of practice, and that's why we have labs to support it, and I walk you through the steps of how it works and why it works in a set of 3 or 4 videos to make sure you're comfortable. The other thing that I want to chat about with OSPF is areas. In a large network, let's say we have just an enormous network with 500 routers nationwide. We don't want to have every router have to listen to the LSAs of every other router in the whole network, because it would just take a tremendous amount of CPU processing to think about all that. So instead we can carve an OSPF network into chunks, like areas, sort of like a VLAN. Think of it like taking a giant room and chopping it up into smaller rooms that only have to remember other people in the same rooms. And those are called areas in OSPF. In CCNA, we deal with one area, area 0, and that's it. And then when we get to the professional level, we'll start breaking it out to multi-areas and area border routers and other really cool stuff like that. So getting back to our network statement, if we want to add all the interfaces on a router, which we're going to do right now, if we want to add all the interfaces that are up and have IP addresses into OSPF, we can do so. I'm going to do show IP interface brief real quick because I forgot which interfaces I have. I'm issuing the do command because I'm in configuration mode. And so the do command says, okay, I'm going to let you issue this show IP interface brief command even though you're in router config. So if I want to bring these 3 interfaces and these 3 networks in, I could do this. Network in router configuration mode for OSPF process ID 1. Network 0000 space, wildcard, 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 wildcard. That effectively says any interface that is up that has an IPv4 address, you're in. So like in my example, I said every street in Las Vegas that starts with M, I want you to be in OSPF. This would be like saying every street in Las Vegas, you're in OSPF on this local router. And so it'll take all three interfaces and bring them in. And then we have to also tell it which area we want to put those networks in. So I'm going to use area 0 by default, and we're using single area OSPF in CCNA, and then we'll increase it as we go to the professional level. All right, so the other thing is, what's really important to do after we make a configuration change? Now, many people might say, save the config. Okay, yeah, we want to save it, so if we have to reboot, it would still be there. Perfect. But it's also important to verify that what we think we did actually happened. So if that wildcard network statement brought those three interfaces, as I look at my routers, if it brought those three interfaces in and OSPF is enabled on those three interfaces, what's a quick and easy way to check? Let me show you. This is the most direct way to verify those three interfaces made it. And it goes something like this. Show IP OSPF interface brief. If we do show IP OSPF by itself, holy spamoli, we get a lot of output. If we do a show IP OSPF interface, press enter without the brief, we get a lot of output, just tons of details. If we just want to verify if OSPF is enabled on the interfaces and what networks were included, this is the beautiful, perfect command that we can do to do just that. If we want to see if there's other OSPF devices on the network and we're forming neighborships, we can do a show IP OSPF neighbor. Won't you please, won't you be my neighbor? Now, can anybody tell me in the chat, can anybody tell me why this beautiful router, router 1, why it's not seeing any neighbors? I'm curious. I'm interested in your input. What do you think? Why is router 1 not seeing any OSPF friends and neighbors who might be sharing routes with them? Because one router by itself with a routing protocol, pretty lonely. Pretty lonely. So as you think about that, if there's no other routers running OSPF, this router is not going to learn anything and not form any neighborships. So let's do this. Let's do a show CDP neighbor. This is a way to verify who we're connected to. So router 2 and router 3 are both on the same networks as router 1 is. So we could go to router 2 or router 3 and just enable OSPF there, and then we can get a neighborship. So let's make a road trip. I'm not making a road trip. I'm not making a road trip over to, wow, look at that. I have several things running on my computer. I think I've just blocked myself. Hold on a second. Let me do a reconnect, see if I can. No, it's not. Wow, that's interesting. That's so cool. So the short story is there. I've got OBS doing the broadcast. I've got an overlay pen that's running. I've got and two other things, and I'm interfering with some of the controls. In any event, if we want to have OSPF neighbors, you have to have at least two routers on the same network segment that both are running OSPF for them to become neighbors. And to become neighbors, here's a few requirements. Let's imagine that you and I are OSPF devices or routers, and we're both running OSPF, and we're both connected to the same network. So you're connected to network 10.16. I'm connected to network 10.16. They're both of the interfaces are enabled for OSPF. And if we want to be neighbors, we have to agree on a few things. You know, like good neighbors would. We have to agree that of what the actual network is. Like if you think that network we're connected to is 10.15, and I think it's 10.16, we're not going to become neighbors. We're not going to agree. If you think it's a 24-bit mask, and I think it's a 25-bit mask, we're not going to become neighbors. If you think it's a broadcast network, and I think it's a point-to-point network, there's concerns there and challenges there. At the CCIE level, there's fun games we can play with that. If you think we should be using authentication, meaning prove who you are, and I think, yeah, it's not so important, or we don't agree on the right type of authentication, that would also cause it to fail. So those are a few other videos I talked about as we go through the building and setting up of OSPF and in a lab environment as well. I'm going to check for any questions that may have come up. And Okay, so question is from Lewis, can an area, and I thank Jake for sending these to me, can an area that's not connected to area 0 communicate to area 0? Yes. So, so we have a large environment, we have area 0, then we're going to have like area 1 and area 2, etc., that are adjacent to area 0, and we have reachability through all the areas. Now, if we have what's called discontiguous areas, we have area 0, all right, area 0, and then area 1, and then area 2, where area 2 is not directly connected to the backbone, we're going to need some kind of a virtual link to logically connect this area to the backbone. So one of the rules for OSPF is you have to follow the rules. One of the rules is they have to have, every area has to have an adjacency or an area border router, some device that logically connects it to the backbone area. So from a CCNA perspective, that would never come up. In the professional level, we'll definitely cover that and work with it, including how to do a virtual link in the event of a bad design. Bad designs happen. I shouldn't call out names right now, but I've worked for several companies where there was mergers that happened and networks that had to be knit together. And sometimes in doing that, we have to do bidirectional NAT, which NAT we'll also talk about in CCNA. We had to do virtual links because the network design wasn't ideal, but we had to make it work until we could do a full readdress of one of the networks. And guess what? If you have two companies that merge, do you know which one gets to do IP readdressing? It's the smaller one usually. And so whether you're on the team on this guy or the team on this guy, a lot of that work gets to be done. It's fun. It's fun. IT is worth it. It's a great. I feel like I'm an underdog in IT all the time. When I was born in '64. That means I'm old officially. I would you want to see something funny? Holy shnikers! Let me see if I can find it. Somebody sent me a link to a video of me from 10 years ago, and said, "Yeah, here it is. I'll show you. Hold on. Hold on. This is a riot." Okay, this is on YouTube, just a public YouTube page, and let me bring it over. Oh my gosh. And you think, well, what can 10 years do? 10 years is, in this case, pretty significant. So I did a thing, well, you'll see. I won't play this for very long because this is a little bit painful for me to watch. And okay, here we go. So that leads us to the next problem. Let's say we go out and buy a switch. So we go out to our favorite Cisco reseller and we say, I want to buy a switch. And they say, well, what kind of switch do you need? And we say, we want to get this switch right here. So whatever model that is, could be 2900 something, 3500 something, 3600 something. So we buy the switch and they say, what GBIX do you need? That's my favorite part of the... Okay, so GBIX is like the old way of connecting to a multi-layer switch with like a fiber connector. But look at that bowl cut, look at the gut, look at the glasses. That's me like 10... it was just posted not too long ago. That's me about 10 years ago doing a class for Cisco in San Jose. Oh my gosh. I'm so happy to be where I'm at. I love what I do. I love teaching. I love making a difference. And let me see if there's any other questions regarding anything that was in the queue. And there's a question that came up saying, do you like routing and switching or security better? Great question. Many years ago, like decades ago, security was not the main concern, at least on the networks I was growing up on. Blue Cross of California, starting in the old days, like 1986, 1987, with coax cable and IPX. But as time went on, security became more important now to the point where security is as critical to be integrated in everything we do, along with functionality. So as far as my CCIEs go, I got my route switch first, then I got my security after that. And I would say for almost anybody who's pursuing CCIE, going for the enterprise, they're changing the name in February, but going for the route switch based CCIE and the enterprise is going to be probably the best first option. If you want to get another one, great, you can go for security or voice or something else, or data center. But I would start with the meat and potatoes, just like we talked about with network automation. Start with the basics. How does it work? How does it function? Learn a little bit of programming. Get a little Python under your belt, some variables. Start using the RESTful API. Start using Postman, and start automating some of those things you used to do manually, and then start moving over to a controller. And there's lots of training at CBT. We can walk you through a lot of that. So for next week, same bat time, same bat channel, we are going to cover, based on the vote that we did at the top of this video, we are going to do DHCP snooping. And let me give you a precursor on that. Back in it was 90s, I went to I guess I can say it. I went to a Novell conference back in the day, and Wi-Fi was fairly new. It was getting more and more available in the 90s. So they rented, we put a security deposit down for a Wi-Fi card, PC card at the time, before USB. So we plugged it in. I had a Windows NT server, again, really, really old. And I thought, I wonder if I could become a DHCP server on this wireless network. And I wonder if I could hand out IP addresses. And I wonder if I could hand out DNS. And the answer is, in those days, yes, because they weren't thinking about security as much as they were thinking about basic functionality. So DHCP snooping is not. It will protect against malicious people who are trying to harm your network, but it also protects against people like you and I who accidentally might. We're not going to accidentally bring in a device from home and plug it in. But if we do bring a device from home and plug it in, if we use one of these ports, and this guy's a DHCP server by default, we could be handing out IP addresses if the company isn't using techniques to protect against that. And one of those pretty simple techniques is called DHCP snooping. So in the CCNA course, I've got a great section of videos on DHCP snooping, some great labs to reinforce it so you can see it, verify it, get a comfort level with it, and then do those again and again if you need to. All right, and it looks like Jake is typing one more thing. I'm going to let him finish so I don't miss anybody's question if he has one for me. And again, I'd like to thank Jake from CBT Nuggets for stepping in and helping me with questions, because I have so many screens up. It's always helpful to have somebody moderate for me and help me bring certain questions to the top. Okay, I got a couple more, and I've got a couple minutes. So thanks for joining me, everybody. Let's take these. You know what I'm going to do? Let me do this. I want to make sure I'm answering the right questions. So if you have a question that I did not answer yet and you'd like an answer to it, this video of this live stream will be live. Well, it'll be stored on YouTube for viewing within probably an hour. So if you want to come back after an hour and actually post that question or any questions you have regarding anything we've talked about or anything we do or any questions here that I haven't answered yet, please feel free to post those, and I go through those probably once, sometimes twice a week. I just block off a few hours and go down and make sure I see every single comment. So for those of you who are joining me today, thank you very much. I appreciate the time. I'm super excited about making a difference in our lives. I think that IT training pays for itself. Every hour we spend training, we're going to save more than that in the production environments. And so it also can help us get better jobs, provide better value for our employers and for our families and for our friends if we just get good at the basic meat and potatoes of networking. So next week, same time, 6 o'clock Pacific time, we'll be joining here for a stream. I'll put up a link in the next 48 hours for that as a reminder. And if you haven't already subscribed, please do so you get alerts, find out when the latest videos come out. And we will continue doing this for as long as there's interest. I love sharing this content with you, and if there's other specific topics that are relevant that you'd like to have enough interest, I would be happy to do those as well. Also, let me know if you like seeing the videos from my studio here at the CBT Nuggets studio, or if you want me to do more live demos, or if you want me to just do whiteboarding, because I don't mind doing all of it if we're moving the needle forward with your learning and education, having some fun doing it. All right, so I am going to say goodbye to everybody. I'll get us some kickoff music here. Let me pick something fun. That looks fun. See you, everybody.